Welcome to this Unreal Engine Quick Start Guide. The purpose of this guide is not to dig deep into all the nitty-gritty aspects of Unreal, but rather to give you an overlook of some key aspects to get you started. In this video, we'll take a look at how to set up materials. But before we jump into Unreal Engine, I'd like to spend a few minutes taking a look at a couple of concepts just to make sure you have a good understanding of the workflow. We'll start with the texture channel packing, a method used to group together a bunch of textures into a single file. This technique can only be used with textures that do not have color information, such as ambient occlusion, roughness, or metalness. Given that an RGB image file uses multiple 8-bit channels, we can use each one of those to place a different texture, resulting in a total storage space of 3 textures, 1 per RGB channel, plus an additional 1 if we also make use of the alpha channel. This will greatly improve memory usage and make your assets more manageable, since you will have to deal with fewer texture files. Now, let's take a look at Material Layering System, a method that allows us to build complex materials by blending together a bunch of much simpler base materials. It's called material layering because you literally stack materials on top of each other in the same way you would stack layers in something like Photoshop, for example. To blend them together, we use masks that determine which portions of each material are going to be shown and where, thus allowing us to add complexity and surface detail. This is, of course, the simplest way to set up a layered material. Masks can be combined in many different ways, for example with a height map. You can use multiple UV channels, different blending modes, and so forth. One major advantage of this technique is that your base materials should be tileable, which means that textile density is not that big of a concern. With all that out of the way, let's jump into Unreal Engine and start setting up some materials, shall we? We will start by creating a master material for our layering system. Once created, double-click on it in the content browser. Go to the Details tab and check the Use Material Attributes checkbox. This will combine all the input pins of the material into a single one called Material Attributes. Click and drag on this pin and in the drop-down menu, look for Material Attributes Layers. Select it. Save your changes and you're done. Now, we'll create a Material Layer Blend asset. This is what we'll use to blend between materials. Double-click to open the graph. Make some room and add a texture sample node to your graph. Right-click and convert it to a parameter. Call it Mask. Now, add a channel mask parameter and call it Channel. Connect the RGBA output of the mask node to the input of the channel node. Connect the channel node to the alpha input of the Blend Material Attributes node. Next, let's add a constant node, and then a Get Material Attributes. We'll add a couple of attributes, base color and normal. Duplicate it. Grab the output pins of input bottom layer and input top layer and connect them to each of the Get Material Attributes nodes. Then add a Linear Interpolate node and connect the A input to the base color coming from the input bottom layer and the base color of the input top layer to the B input. Lastly, convert the constant node to a parameter and name it Color Opacity. Connect it to the remaining input of Linear Interpolate. Now, add another node to the graph. This time, we'll need a Blend Angle Corrected Normals. Connect the normal outputs of the Get Material Attributes in the same order you did before. Let's add one last node to our graph. Set Material Attributes. We'll add a base color and normal attributes like we did before. Connect Linear Interpolate and Blend Angle Corrected Normal to the corresponding inputs, and the output pin to the B input of the Blend Material Attributes. Connect input top layer to the Set Material Attributes node and you're done. We will create yet another master material. This one is unrelated to the layering system and will only be used for regular non-layered materials later on. The procedure is quite simple. We just need 3 texture sample nodes, convert them to parameter and name them base color, normal, and ORM. The base color and normal textures just need to be connected to the corresponding inputs of the material. The ORM texture is going to hold a channel packed texture, so we will have to connect the R or red output to the ambient occlusion pin, the G or green output to the roughness pin, and the B or blue channel to the metallic pin. Additionally, we can create a duplicate and connect the A or alpha channel output to the emissive for materials that will use an emissive texture. In this next step, we are going to create the shared material library that we'll use in the layering system. Now, before proceeding, make sure that all your ORM textures are set to masks, no sRGB, in the compression settings. Right-click in the content browser to create the first material layer. It's going to be a bare metal material. Double-click on it. Create 3 texture sample nodes. Assign the base color, normal and ORM textures corresponding to the metal material to each one of the texture samples. Now, let's add a constant and convert it to a parameter called roughness. Next, we'll create an add node. Connect the G or green output of the ORM texture to the add node, and do the same with the roughness parameter. We will now combine all our textures using a Make Material Attributes node by connecting each one of them to the corresponding input. Remember that the ORM map contains multiple textures: ambient occlusion in the red channel, roughness in the green channel, and metallic in the blue channel. Last but not least, we will add some parameters to control the tiling of the textures. Create one text coord node and a couple of constants. Remember to set the coordinate index to 1, since that's where the UVs for the tiling materials are. Add two more nodes, append vector and multiply. Connect text coord and append to the input pins of multiply. Set the default value of both constants to 1 and convert them to parameters. Connect them to the append node, but remember to call the one connected to the A input U tiling and the one connected to the B input V tiling. This is important because U refers to the tiling on the horizontal and V on the vertical. Finally, connect the multiply node to the UV's input pin of each of the texture samples. Here I noticed a mistake. I plugged the normal texture where the ORM should be and vice versa. That's an easy fix. To create the next material layer in our library, simply duplicate the one we just made by pressing Ctrl D. This time we'll be creating a dust material. Open the graph and replace the textures in the texture sample nodes with the ones corresponding to the dust material. For this particular material, we won't be needing the roughness parameter, so remove it, along with the Add node, and connect the green output directly to the roughness channel. Let's add a constant 3-vector node. And a blend darken node. Connect the base input of this node to the RGB output of the texture sample corresponding to the base color. Set the default color of constant 3-vector to white and convert it to a parameter called color. Now connect its RGB output to the blend input of blend darken. To finish up, connect the blend darken output to the base color channel. We are done setting up this material. For our third and final material, we will create a painted metal by once again duplicating the one we created first. Just like we did before, we'll replace the textures in the texture samples by the appropriate ones. In this case, the painted metal textures. This time, we are keeping the roughness parameter, and we are also going to be adding a color parameter using a constant 3-vector and a blend darken. We'll just follow the same steps as before. Done. Time to create our first layered material. Right-click in the master material we created first and select Create Material Instance. For the sake of keeping things organized, I suggest you put your layered materials in your asset folders. As you can see in the Details tab, the parent of this material instance is the master material we originally created, which means that any changes we make on that material in the future will be reflected in the instance. Currently, there's only the default background layer. Let's populate this layer with the painted metal material layer we created earlier. Just select it on the content browser and press the Use Selected Asset button. As you can see, not only is the material now assigned to the layer, but the parameters we previously created are also visible. Moreover, we can actually edit them. For example, we can increase or decrease the UV tiling very easily. Likewise, we can change the roughness value to make the material as glossy or as rough as we want. And we can even change the color. As you can see, this workflow makes it very easy to customize your materials. Before continuing with the layered material, let's assign it to a mesh so we get a better preview. Time to add another layer. Press the plus button next to Material Layer. This creates an empty layer on top of our background one. Let's populate it by placing the bare metal material in the Layer Asset slot. To blend between the two materials, we'll need a mask. First, add the material layer blend we created earlier in the Blend Asset slot. Pick a texture file and place it into the mask slot. Since this file is a channel-packed texture, we'll have to select the channel that contains the specific mask we want to use. If you are uncertain as to which one is the most appropriate one, feel free to try them all until you find the one that looks best. In this case, we'll select the alpha channel. Once we are happy with the results, it's time to add yet another layer. This one is going to add a little bit of dust on top of the metallic surface. In the same way we did before, first we need to populate the Layer Asset slot. Remember that, just like the painted metal material, we added a color parameter to the dust material. Feel free to adjust it to your liking. Then add the blend asset. Finally, select the mask file . For the dust layer, we will choose the mask stored in the green channel. This setup is very flexible, for it allows you to tweak material settings dynamically. You could continue adding layers to include things like rust, oil, etc. But keep in mind that a higher number of layers will have an impact on performance. Use them wisely. To wrap up this video, we'll take a quick look at how to set up a standard material using the second master material we created earlier. It's very easy to do. I found an issue in Unreal where if you leave the texture sample parameters with the placeholder texture in the master material, the textures don't work correctly on the material instances. I might be doing something wrong here. As a workaround, what I usually do is simply replace the placeholder textures with some of my own. In this case, the textures for the winch. Let's now create the material instance and move it to the asset folders. Since the material instance already has the winch textures assigned, there is nothing else for us to do here. The only thing left to do is to assign the material to its corresponding mesh. Let's duplicate the winch material. We will now create the material for the tires. All we have to do is open the material and replace the base color, normal and ORM textures. Assign our newly created material. There you go. That's how easy it is to create a standard material. I hope you found this video helpful. We barely scratched the surface of what can be achieved with Unreal Engine's materials. If you'd like to dig deeper, I would encourage you to check the extensive documentation available as well as the developer forums over at unrealengine.com. You can also join my Discord server, where I'll be glad to assist you in any way I can. See you soon.